Campus A field of Western Mindanao State University, and we're going to vlog about our topic, which is the CRISPR edited cells linked in cancer in two studies reviewed by
Me, Nicole, Leah, Martinez.
and Charmaine F. Cuaresma.
So, CRISPR, or you can pronounce it as CRISPR, actually stands for Clustered Regularly Interspaced Short Palindromic Repeats, which are the hallmark of bacteria system defense that forms the basis of CRISPR-Cas9 genome editing technology. So, this topic is all about science and how it affects cells that results cancer and explains why it occurred. So, many researchers and experts has their own conclusions about it. So, according to Tina Hermensay, CRISPR gene editing has held the promise of curing most of the over 6,000 known generic diseases. In this first clinical trial, scientists are using CRISPR-Cas9 to combat cancer and blood disorders in people. So, in this test, researchers remove some of a person's cells, edit the DNA, and then inject the cells back in, and hopefully armed to fight disease.
So experts are taking the cancerous findings seriously. Other groups tested different kinds of human cells like retinal cells. They found out that an injury can cause a cell to activate a biochemical first aid kit, which either mends the DNA break or it may cause the cell to self-destruct. So other researchers see how CRISPR-Cas9 works in human bodies, inside the human body. So they have argued that CRISPR-Cas9 only worked in the cell of an animal and not on human cells. So as a proof to their predictions, they have experimented paralyzed rat, and the experimentation was done successfully. While for the human cells, some kids had a therapy for immune defects, developed cancers. Blindness therapy worked temporarily, but it could not hold the disease progression. So, sad to say, but the participants died taking part in these gene therapy trials. And now the researchers have had success in using the gene editor CRISPR-Cas9 to correct disease in animals but failed on humans. So to make it more clear, CRISPR-Cas9 technology can directly cause a cancer induced as a gene called tumor protein, which encodes a protein that functions to repair DNA damage and present tumor functions.
So the CRISPR was agreed upon a label for those still mysterious gene regions. So adjacent to these were constantly found a number of sequences which had the hallmark of actual genes. These two were of unknown biological purpose and were therefore assigned the similarly nebulous name Cas, which is CRISPR-associated genes.
So the discovery of the CRISPR-Cas microbial adaptive immune system and its ongoing development into genome editing tool represents the work of many scientists from around the world. It presents a concise history of the seminal contributions and the scientists who pushed this field forward. So thanks to Francisco Mojica, which was the first researcher to characterize what is now called CRISPR locus.
He worked on them throughout the 1990s and that 2000s. He recognized that what he had been reported as disparate repeat sequences actually shared a common set of features. So, NKA known to be hallmarks of CRISPR sequences. So, CRISPR is a fascinating and a powerful technology. The name actually refers to how or the way how it interacts with DNA. It's a way to manipulate DNA, to edit DNA in a way that's much more powerful than previous methods, much simpler, much cheaper, and the most important part, it is exceptionally precise. The studies are about the human cells and animal cells. It demonstrated that genome editing using CRISPR was capable of including a mediated DNA damage response, which caused a high percentage of cells to die. Some authors even concluded that the CRISPR-Cas9 was highly toxic to their stem cells line. So in 2017, Scientist uses CRISPR for the first time to repair a genetic mutation that could cause a heart defect in an embryo.
So now more immediate concerns have arisen about CRISPR, and series of studies have suggested that it may cause cells to lose their cancer-fighting ability. Half dozen companies are racing forward to try to proceed with using CRISPR for various applications. So for the conclusion, CRISPR was surely the revolutionizing modern biotechnology and molecular biology. This technology have shown that they are present in nearly 40% of bacteria and 90% in archaea.
It is powerful and it caught most attention for the potential medical application and purposes. So CRISPR has given a great amount of hope to billions of people by making them believe that this tool may give them a longer life or it may trigger the disease to be more dangerous.